CBSE board examinations, intermediate public examinations, chemical bonding, short answer questions. I explain here how to write the answer and the basic idea of the concept. Fine. Explain the hybridization involved in PCl5 molecule and SF6 molecule. These kind of questions will come. In PCl5 molecule, phosphorus undergoes sp3d hybridization. You make these terms as small letters, sp3d. Shape of the molecule is trigonal bipyramidal. Bond angles are 90 degrees and 120 degrees. Okay, so here phosphorus 1, 2, 3 chlorine atoms. In the plane, between them the angle is going to be 120 degrees. One is above the plane and one is below the plane. If you mention these lines, that's enough. Okay, because of these statements you will be given complete marks, don't worry. SF6 molecule, sp3d2 hybridization. SF6 molecule shape is octahedral. Bond angles are 90 degrees and 180 degrees. This is octahedral geometry, you can see here. 6 bonds are there, 90 degrees and 180 degrees, octahedral. Mention this very clearly. Hybridization, sp3d2. If you mention like this, the paper evaluation person will see only this data. They won't read all the nonsense what you write. Okay. State Fuzan's rules. Yes. Fuzan's rules and give suitable examples. Fuzan's rules explain the partial covalent character of ionic bonds. First, briefly, I will say large cation, plus I am writing cation, small anion, ionic bonds. Reverse, small cation, large anion, covalent bond. Over 2 points. Then less charges, low charges favor ionic bond, high charges favor covalent bond. Inert gas configuration, ionic bond, pseudo inert gas configuration, that is covalent bond. Right? Now you see how we write. For a given cation, covalent character increases with the increase in size of the anion. Covalent character increases with increasing charges either of cation or anion. SnCl4 is more covalent than SnCl2. Here it is +4 oxidation state, here it is +2. For a given anion, covalent character increases with a decrease in size of cation. LAF is more covalent than KF. Covalent character is higher for compounds with a cation with a pseudo inert gas configuration than with inert gas configuration. CuCl pseudo inert gas configuration, sodium chloride inert gas configuration. Don't think too much about the pseudo inert gas configuration. If S2P6 is there, inert gas configuration. If D10 is also there, pseudo inert gas configuration. 18 electrons. Okay. Fourth question. Define dipole moment. Write its applications. The product of magnitude of charge on the poles and the distance between the two poles is called dipole moment. Mu is equals to Q into D, or you can write mu is equals to dou into L. Anything is fine. Dou is charge, L is length, or is a distance. Where it is going to be useful. Geometry of molecules can be determined, because if the geometry is perfect without any lone pairs, dipole moment will be 0. Percentage of ionic character of a bond can be calculated by using the formula percentage of ionic character is equal to mu observed by mu theoretical into 100, or you say mu calculated into 100. Percentage ionic character can be calculated. Cis and trans isomers can be, don't say separated, can be identified, can be tested. Bond angle can be determined. Okay, these are the applications. What is hydrogen bond? Explain the different types of hydrogen bonds with examples. First you give the statement, then you give the types, then you give the examples. That's all. The weak electrostatic force of attraction between a partially positive charged hydrogen atom and a highly electronegative atom like fluorine, oxygen, nitrogen of the same or different molecule is known as hydrogen bonds. Hydrogen bonding is of two types: intermolecular, intramolecular. Intra means within the molecule. Orthonitrophenol structure I am writing here. This you see, this is benzene, OH is phenol, NO2 is nitro. This is hydrogen bond. So within the molecule hydrogen bonding is intramolecular hydrogen bond. The hydrogen bond formed between two atoms of same molecule. If the hydrogen bond is formed between the two different polar molecules, it is called intermolecular, like HF. If possible, write like this. And the structure is mandatory. Explain the formation of coordinate covalent bond with one example. The bond formed by sharing of electron pair is contributed by one of the bonded atoms, and second atom will be having only vacant orbital. Then the bond formation is known as, the bond formed is known as coordinate covalent bond. The bond formed by sharing of electron pair contributed by only one of the two atoms. That means both electrons are coming from same atom. Actually, covalent bond means each atom provides one electron. Here only one atom is providing electron pair, second atom is containing only just a vacant orbital. The bond is represented by an arrow pointing from the donor to the acceptor. The atom which donates electron pair is called donor, Lewis base, and the atom which is accepting electron pair is called acceptor, that is Lewis acid. So here nitrogen's lone pair of electrons are going towards H plus, and here you can see this H2O, H plus, H3O plus. Like this also you can write. One more question. Even though both NH3 and NF3 are pyramidal, NH3 has higher dipole moment compared to NF3. This is entrance question also. In case of ammonia, the orbital dipole moment due to lone pair of nitrogen is in the same direction as the resultant dipole moment of NH bonds. Whereas in NF3 molecule, the orbital dipole moment is in the direction opposite to the resultant dipole moment of 3 NF bonds. See, this is the lone pair of electron. And now electrons are coming like this. Okay, electron flow is towards nitrogen. Resultant dipole moment will be there. Here you see, fluorine is more electronegative. It's going outside. Got it? Here hydrogens are less electronegative, so all the electrons are coming onto the nitrogen. So nitrogen is already having a lone pair, and again electron pairs are coming towards the nitrogen. So overall electron density will be more, in simple sense you can say. That's why it will be having great dipole moment. And in simple sense, if you want to remember like this. If the attached atom is with less electronegativity, then the dipole moment will be more. If the attached atom is having great electronegativity, then the dipole moment will be minimum. This you can apply whenever hydrogen fluorines are attached. Show how double and triple bonds are formed between carbon atoms in C2H4 and C2H2 respectively. In C2H4, ethylene, carbon atom undergoes sp2 hybridization. 5 sigma bonds and 1 pi bond are formed. 4 marks, na? It's enough to write. See, double bond C, it will be like this. There are 5 sigma bonds and 1 pi bond. In case of C2H2, there will be sp hybridization. It will be having structure like this. Got it? So these are the important short answer questions. If you write this information, that is enough for 4 marks. Don't think that I will write all the things I know, because in your examination time is very important. Okay, now time, role of time is very, very important. Maybe you know all answers, but you need to write the answer according to the marks. If it is 4 marks, you write like half page like that. If it is 8 marks or 6 marks, then you write by elaborating. Thank you. Done. I want to see all the 60 marks, all the 100% marks. Okay. Next topic is states of matter.